Hello everyone, my name is René. I'm very happy to be here today and share with you a little bit our experience, or my experience, how we run our own e-commerce solution on the cloud. I will talk a little bit more about the solution which we built, and then Marco from copebit will tell you a little bit how we run it and also a bit about the complexity it is. So first, quickly about the company, Sly AG, then about the solution Velox, which I hope you all know. It's the most amazing, newest microservice-based e-commerce solution, open source. A little bit about the project, which we are currently working on together. And then Marco comes up with all the interesting stuff, how we run it. And there is also a little demo I heard about how to do this. About myself, I work in IT already for a while, a bit more than 25 years. And the only thing I know in IT is e-commerce, B2B e-commerce. So I do this for more than 20 years. I worked for different companies, still doing the same, because that's all I know. Sly AG is an engineering company. We run e-commerce applications, or we build e-commerce applications for industry and retail. Why B2B? What's the difference? What we experience in B2B is that there is a lot more of integrations. Very often B2C applications, they run on monolithic standalone systems, while in B2B you have a lot of integration. CRM systems, PIM systems, ERP systems, real-time price calculation, availability integration, and that's something which we think doesn't run very well with some of the standard solutions we worked with. Some of our customers, and what's really interesting, our company only exists in 7 years, but a lot of the customers I already kind of support since almost 20 years. They're from different areas, they're resellers, there's startups, there is Amag Auto Importer, I think all of you know a little bit about it. So for us it's really long-term relations to our customers, and quality is really important. The company is Swiss-based, we're here in Zurich, all our employees are in Zurich. We also are Swiss-made certified, so we really try to do everything here with our team locally. We also look for local customers in the area. We don't try to do international projects. We use a lot of open source. I think we all do use a lot of open source, and we also try to give something back. That's also why our own e-commerce solution is also open source. And we are founder and member, there is a laser pointer, I guess. Ooh, fancy. Of Swiss Tech Hub. I will tell you a little bit about the Tech Hub later. So Velox, why? Why do we need another e-commerce solution? I guess some of you know about Shopify, maybe Magento, maybe SAP solutions. Why did we create one more? The main reason is our customers, when they buy a solution, they also always want to have a standard solution, right? They look for something which many other companies are using, and which is kind of proven, which is best practice, but the result they expect at the end is kind of a full tailor-made solution. Our experience is with the standard solution, you can build a lot of different stuff, but there is limitations, right? You can't start with the single-story house and build a castle, or the Eiffel Tower, or something else. You can do that with tailor-made, but the initial costs to do this is intense. It takes a long time until you can show your customer result. And that's why we thought about a different approach, where you can build at the end tailor-made solutions, but you don't have to start from zero, right? That's why we tried a different approach. So the majority of e-commerce solutions, that's on the left side, they try to have everything inside the e-commerce solution, right? So they try to have a customer base, a CRM system. They try to be able to maintain products in the e-commerce solution. They try to have CRM functionality to kind of track the activities of the customers and the contact. They always have CMS. Not sure if everyone knows what the CMS is. Content management systems is to maintain website content. So every well-known e-commerce solution, they implement their own CMS system, right? Our approach is a little bit different because we think that e-commerce, how we build it today, is more an integration of existing solutions and not something very complex, which have to implement all those stuff. So what we try is, for each customer project, we try to find the best solutions for all those cases: product information management, customer information management, availability, search, and then we integrate it. And our web shop at the end is a small piece of software compared to the complex monolithic systems, which is more like a middleware to connect all the systems together for the front end, to deliver a headless API, and then to build a really nice and slim software instead of having a huge system where at the end you will only use a little part of it, right? I mean, every one of you uses Word. Not sure how much of Word you use. I use 2%. Maybe some of you are power users and they use 8%. I guess no one of you is using 50% or 80% of Word, Excel, or all this stuff. And the same is also with the standard e-commerce solution, right? You buy a software from SAP, Hybris, Cloud Commerce. You pay, I don't know, 100,000, maybe a bit more for a license, and then you use 5% of that software. And while we customize this software for the customers, at the end, we more work against the solution instead of with the solution. Can we rip apart the solution and try to integrate things which maybe are not meant to be integrated there, right? And that's why we have this different approach. Velox is not really a product. It's not a solution. There's no installer, there's no setup. It's more a foundation to build tailor-made e-commerce solution. We can deploy a shop for the customers within a few days. Then we have a running system, which is more like an empty e-commerce shop. And then we start building the pieces for the customer and also removing pieces because it's a new architecture microservice. It's open source, and we have a demo store which we can install right quickly. So what's the difference? It's much more flexible. For sure, it's very, very scalable because it's not a monolithic system. There is no license cost, and as I said in the beginning, it's open source. So we want to share it with others. We don't think that because we use it, we want to keep it for us, right? We think when other people are using it, it will also benefit. And we are not scared from other people using it because we think that at the end, our know-how on how to make a great tailor-made application out of it is also important, and not just the software using it, right? At the end, if you buy a standard solution, it's always about the people help you to build it to what you really need and not what the solution was in the beginning. There is different scenarios how you can use Velox for your e-commerce needs, right? It's a headless microservice architecture, so you can integrate it seamlessly into your existing website, right? You can build complex e-commerce solution. You can only use certain modules, which we already did a couple of times. We also try to migrate bigger online shops, not in one step, but to first migrate some smaller services step by step, and after a few months, maybe sometimes a bit longer, we have 80% of the solution on our solution, and then we can kind of, the rest is still work, right? We can also build smaller shops, standalone e-commerce, or we can just add a checkout to existing applications which are not a full-blown web shop, right? That's also something we're doing right now in the area of crypto, NFT, gold. Really interesting project. This is the architecture. I don't want to tell you too much about it. We didn't invent it, right? It's service-oriented architecture based on microservices. It's not something new. We just kind of implemented the first 30% of how to build a web shop on microservices. And that's what we try to reuse for our customers. In some projects, we use all the modules. In most of the projects, we only need, like, at the end, 50% or 10% of the modules. Doesn't matter, because since it's microservice architecture, we can just drop some of the modules, and they're no weight anymore for us. In monolithic system, if you don't use modules, they're still there. Whenever you build, whenever you deploy, they're still there. And that's our approach of being much more flexible and being able to cherry pick the modules we need for a certain project. One project we're working right now, it's also one of the first projects where we do a full-blown web shop. In the first few projects, we only implemented smaller modules for e-commerce. That's the first one where we do the full implementation, full web shop, website, integration into all the systems, and we also run it. And we are software engineers running a software for a customer. So not sure how that comes. I told you it's a lot about integration. So we have the customer on the left. We have our really, really small microservice-based web shop in the middle. We have an ERP system. We have a PIM system. We have a DAM system. We have an identity management system and a CMS system. And we integrate everything together to have a working web shop at the end. I told you we're an engineering company, mainly in software engineering. And whenever we do a bigger project, we need colleagues. We need collaboration. That's also why we have TechHub Swiss. It's an association to network, to connect IT suppliers together to be able to give better services and full services to the customer. So we don't try to connect customers and suppliers. We try to only connect the suppliers to be able to collaborate on bigger projects. That's also how I know Marco. And you see already here on this project, our company was responsible for project management, for back-end development, for consulting. We had a member of TechHub doing the front end, copebit doing the whole infrastructure. We had a guy doing penetration testing and security, also code reviews. And we had a graphic designer, a freelancer, not yet member of TechHub, but maybe soon, who was doing the whole graphic design. And that's kind of how we want to do projects. We're a small company and we don't want to grow kind of to be a full service provider. We have our expertise, and I think there is a lot of small companies around our area who have their expertise, and we think the collaboration is better than being bigger and bigger and bigger. So, challenge. We have a microservice solution, and we know we run it on the cloud because we don't have server rooms anymore, right? And we don't want to buy hardware and put it in a rack space, right? So it was pretty clear that we want to run it on Kubernetes, right? Because we heard a lot from other guys that it's really great. We had a little experience doing it, but not too much. For me, it was also clear I want to run it on AWS because I run system for more than 10 years on AWS now, with very, very different style of running it, very different style of installation, and various different styles of setup. So a bit about how we run Velox so far. So the first project we did in 2022, so we started with some, for sure, first we did ECS systems, or EC2 systems, and just installed it on the command line. For sure, after a few months we were not happy with it, and we started using ECS. And for infrastructure as a code, we started using Amazon CDK, which is kind of a scripting language to create your infrastructure. GitHub, I think that's all good. And then we started building a demo shop around the same time, and again, EC2 system, and we just run it with Docker Compose. It worked well, because with every deployment, we just kind of reset the data. We started from new because it's a demo system. Anyway, everyone playing around is just making a mess. So we didn't have persistence. We didn't have kind of release problems with changing data models. We could just kind of delete and work again. And then we had our first really bigger project, Sonepar. It's a big electronic reseller. And we didn't build the whole web shop. We just built one service. So it's 4 custom small services for, it's called the delivery control service. So when the parcels arrive at the building site, you have all the boxes with the barcodes, and in the box, the products with the barcode, so you can use your app and say, everything is here, everything is here. Because the customer wanted to run it on Azure, we didn't have a lot of experience, so we also collaborated with someone So we used container apps, and for infrastructure as a code, we used Bicep, which was pretty new, but it was quite easy to kind of adapt. So the first subscription we made manually and then exported it and then could regenerate it. And then copebit helped us in 2023 to run Velox the first time on Amazon on Kubernetes with Terraform. Setup worked great, but we also knew from the beginning this is not a production environment, right? That's still a demo system. And then I think, because I knew my limitations, I thought, okay, when I run a customer project production on Amazon, I need some help. And that's where Marco came in place.
Great, thank you so much, René, for the introduction into Velox and how you work on Kubernetes on AWS. Thanks everyone for being here. We are so glad to host you today. So we are sponsoring this event and so glad that you all came. Big crowd today, that's really great. So my name is Marco Kuendig. I'm the CTO at copebit. I have been with the company for roughly 5 years and working hands-on with. So I have worked with René on the Sly Velox case for the last 18 months or so. And René told you that we did a small implementation as a demo setup so that they could see how Velox could run on Kubernetes. And now, as they had a first production-grade customer, we have done it properly. So we well architected it, built a really good landing zone, and put all the services that they need into a real architecture with real services below that are really well optimized and well architected. So what do they use? So they have a lot of day 2 services for operating, patching, monitoring, logging, and all of these things, all based on AWS. And then in the middle, we have the workload stuff, Kubernetes cluster, of course, EC2 instances, RDS, DocumentDB, OpenSearch, all of it modeled in infrastructure as code and deployed very easily to these separated AWS environments. And here you see also we have not only integrated it as the infrastructure automated, but also the pipelines. So whenever the software developer changes something, the code is merged. It is also deployed automatically to the Kubernetes clusters via Helm chart, so building, testing, deployment via Helm charts to the Kubernetes clusters. So infrastructure with Terraform and application deployment with GitLab gives a clear separation of duty between the different teams operating that environment. And of course, it's all based on AWS services whenever we use open source services so that we don't have too much complexity in the setup. On the Kubernetes side, of course, we integrate very closely into the AWS platform. So, for example, the secrets are offloaded to Secret Manager. The load balancer are all provisioned with load balancer controllers so that we have properly set up and properly secured load balancers. And the storage integration is also well done for block, file, and object storage into the AWS platform. As said before, everything modeled in Terraform, so very easy for the Sly folks to do changes, to operate it, and also have it documented at the same time. Now, the whole platform that we have built, because it's an e-commerce system, is auto-scaled. The databases are auto-scaled, the Kubernetes cluster is auto-scaled, and as we are here at the CNCF Meetup, I want to show you how we have auto-scaled the application and the worker nodes below on the Kubernetes side. So we are using Carpenter for that. So with Carpenter, we do have a technology that really helps us to auto-scale the nodes underlying the Kubernetes cluster. So on the first level, you see, you first need to auto-scale the application. So if there are not enough pods, you see that the CPU, the memory is not enough, so then you add more pods to it. But that doesn't help if you don't have enough node capacity underlying. So for that, Carpenter comes in. So Carpenter is actually helping to see when there is capacity needed that is not there and launches that capacity in very quick manner into the Kubernetes cluster as the autoscaler. So we had autoscalers in the past for Kubernetes, but they were really slow and clumsy to use. But now with Carpenter, we really have a good solution that brings in capacity within seconds. So we don't have to wait 10 minutes anymore as in the past, and the peak was already gone when the capacity was available. With Carpenter, we really get the capacity within 30, 45 seconds, something like that, and the pods are online and can serve traffic really quickly. And also, if the load goes down, Carpenter removes that capacity, and you only pay the capacity that you really need. So basically, Carpenter autoscaling brings you something like serverless capacity to your Kubernetes cluster. Here you see how Carpenter works. So first we have pod autoscaling. So you need to have a mechanism to add more pods, because when you add more pods, need more capacity, then you get pending pods. You see that later on in the demo, how that actually works. So these pending pods, they actually trigger an event that Carpenter sees in a cloud-native way, and then Carpenter goes and queries the AWS API to see which is the best instance to host the pending pods that you would like to host on Kubernetes. So the Carpenter has two elements in there. The node pool, that's a provisioner, where you actually define what kind of capacity that you would like, spot instances, on-demand instances, or something like that. And then you have the node template, and in the node template, you define the node, how it should look like. So what kind of storage, the AMI is defined in their software that should be installed, maybe some user data scripts that you would like to run, stuff like this that comes from the node class. And then when Carpenter kicks in, talks to the API, gets these instances within seconds, they are added to the Kubernetes cluster within seconds. So really cool what you can do. And here the Carpenter node definition, you see it's very flexible. You can define what kind of instances that you would like, what generation, what technology, what CPUs, stuff like that. All of that can be defined. You can also define SKU if you want to spread it over multiple AZs. Of course, the regions, of course, it should be in the same region as the cluster is. AMD, ARM, Intel, Spot, on demand, what you should be in, what should not be in, all of these things can be defined, and then you have the cluster ready to go and rock and bring these instances there. The really best thing about Carpenter is you can use it with Spot instances. So Spot instances, as you probably know, are about 60 to 70% cheaper than normal instances. How can you use that? Because Carpenter actually queries the AWS API and sees what capacity is available, and it also compares the prices of it. So you really get the best instance that you require at the lowest price that is available right now. So we very often see for our clients that very fancy, very fast instances are coming up because nobody else uses them because they think they are too expensive. But actually Carpenter sees that they are so cheap right now that he picks it and puts it under the workload. So a really good benefit. And also it has the ability to query all the instance types that you have defined. So you don't only query T3 or T4 or M5, you query all of them. And because you query all of them, you get the best price over the whole fleet. So there's very likelihood that you get an instance and you get it at the best price. And Carpenter is also intelligent enough to see in what availability zone it needs to be. It has storage awareness, so if you need an EBS volume on that node, the Carpenter brings it in the right availability zone with the right connection so that your pods can be launched. As we are using Spot, we also need to see that the Spot interruption is handled properly. So you probably know AWS can take away a Spot instance within 2 minutes, and that is signaled to Carpenter, and that is done via SQSQ. So if your instance goes away, you get a notification via SQS. Carpenter sees that notification and launches another instance. So you already have another instance up when the impacted instance is going away. So that means even if a Spot instance goes away, there is no impact to your application, which is really cool, and that lowers your instance costs dramatically. Another feature of Carpenter which is really cool is the optimization that we can do. So we basically can consolidate instances that are there. So let's assume we have every 5 minutes we have a job running that needs capacity. So the capacity is coming online, 5 minutes later more capacity is coming online, another 5 minutes more capacity is coming online, because Carpenter always chooses the smallest instance that he can do. So after maybe half an hour you have 6 instances up and you pay more because you could consolidate these jobs, pods, onto a smaller instance. So Carpenter does that and sees on a regular basis, can we consolidate instances and save even more. Good, now it's demo time. Let's see if the gods are with me today. And this is using the cloud, so it's real life what we have here. I need to stay at my laptop so that I really see what's going on. So 2 small demos that I have prepared. So here you see a split screen of a connection to an AWS account where I have prepared a Kubernetes cluster with Carpenter installed. So on top here, you see right now we do have 3 nodes running. 2 Fargate nodes, that's actually where Carpenter is hosted, because Carpenter also runs on the Kubernetes cluster. And then we have the stock standard node on it, which is a pretty small one, a T3 large, which comes with the cluster. So right now we don't have any real workload running on that cluster. And the bottom here you see I have prepared a small demo where we can inflate a deployment. So right now that inflate deployment has 0 pods associated to it. So let's see if I scale that up to 5. So let's see, we have an application, we want to scale that up, and we do that manually right now. We just add 5 pods to it. So immediately you see that up here the capacity can be put on here, but we still have 5 pending pods because there is not enough capacity available on the worker nodes. So if you look closely here, you will see in a couple of seconds that a new launched Carpenter worker node is coming up. So what happens here, as said before, Carpenter has seen that we have pending pods, and these pending pods are triggered, trigger an event on Carpenter. Carpenter goes to the AWS API, fetches for the cheapest instance, and launches it in. So you see it took about 20 seconds to get the instance in, and here you see all the pods are now fully ready on the node itself. Here you also see that no more pending pods are needed. The scaling worked. So the first demo was nice to me. So let's now see, let's say we have a big event coming in. Let's say we have Black Friday. We want to have 50 new pods coming up. So you see the old node had a bit of capacity left. It could launch 7 of the pods that are launched from here, but we still have 43 pending pods that cannot be satisfied in the cluster right now. So now we need to really add a big instance. So each of these pods is using 1 CPU. So we are adding about an instance with about 50 CPUs on top of it. So here you see, I talked enough, and the C6A12X large is coming in. So that's quite a costly instance, and it took about 10 seconds for Carpenter to get it. And if you look now up here, it has already started to put pods onto it. These pods are starting, and the capacity is there. The instance is ready, and more and more of these pods are really serving traffic, integrating into the load balancer, serving traffic. So you see how quickly that all goes with Carpenter and how it scales up and down really easily. We don't have the time to wait now for a consolidation, but what would happen now is, because there is a bit of capacity left over here, this is quite a large instance, in about 10 minutes or so, it will consolidate the 2 into 1. So that would remove one of the older instances and consolidate it into the other one. But because of timing, we shut this one here down. So we remove these replicas. So you see the big instance was emptied. Also the smaller instance was emptied. We have no more pending pods. We have almost no workload running. So this is just the daemon set pods that are running, the system management pods. So if I talk long enough, so it takes about a minute or so, then these two instances should disappear as well. So Carpenter is not only scaling up the instances, but also scaling down. And that's a real cool thing, because we are now using spot instance with interruption protection and have also the SQSQ integration. That brings us a really fantastic worker node setup to the Kubernetes cluster without much that you need to do. Has it already disappeared? No, not yet, but it will. In the meantime, I'm going to explain you the next demo that I'm going to run. So I have talked, so the first one has disappeared. Have you seen that? Yeah, so one has disappeared automatically, and the other one should be removed as well pretty soon. So this is node autoscaling that I have shown you with the EC2 instances with Carpenter. Now the next demo will show you how we are going to do horizontal pod autoscaling and Carpenter in combination. But before I can start that, I need to kill that node here. And, because of timing, I'm going to do that. So we are going to delete that one. Oops, what's up? Oh, it's already gone. I missed something. Yeah, you're right. Thank you. Good. Killing. Oh, now it's gone. Now what's up? It doesn't want to go, so let's see what's happening here. No, it's gone. It's gone. Good. It's not updating for some reason, but it's already gone. Good. So here we are coming to the second demo. So where we combined HPA, horizontal pod autoscaling, and Carpenter at the same time. So let's do that. So here you see we have an Nginx running here. So right now we have 3 nodes running, the 2 Fargates and the other one, and we have one Nginx pod that is running. So that's in the middle here. So now I'm going to stress test this. So I'm using Apache Bench, and with Apache Bench, I'm actually sending a lot of queries to that Nginx pod with the load balancer in there. So what happens now is Apache Bench simulates about 250 clients sending lots and lots of traffic to that Nginx pod over the wireless LAN. So let's see if the Blue Lion wireless LAN works well here. So it's a lot of traffic that we are sending in. So what should happen next is that we should soon see that, I don't see this a bit big. So here, I scale that a bit. So soon here the CPU cores should go up. Now you see here, so the number of pods have already started to increase because the CPU has started to go up. And the horizontal pod autoscaler is configured to be triggered above 10%. So I made that on purpose for this demo very low that it scales quickly. So you see that the number of pods are going up all the time. So we also see, we don't see it right now because it doesn't work, but here, now it updated again. So here you see that we have 7 pending pods, and these 7 pending pods cannot be satisfied on the underlying nodes. So what should happen now, Carpenter should kick in, and it has already kicked in. So you see, we have number of nodes. We already got 2 new nodes coming in. You see that here as well. Yes, so it's now updating again, thanks Demogod. So here we have new instances coming in. And at the same time, here Apache Bench has stopped to hammer the Nginx. So what happens is now the CPU load decreases on these pods, so it starts to scale in automatically as well. So HPA is not as quick as Carpenter is. So HPA takes about 30 seconds or so to recognize that the load is lower. But as soon as the load decreases, we should also see that the number of pods are going down. And if the number of pods are going down to 1 at the end, we don't have the pods running anymore on these worker nodes, and then Carpenter starts to remove as well that capacity from the EC2 instances. Good, so you see HPA has scaled down. We are back at one pod down here. You see the capacity has been released up here. So these instances, they should go away pretty quickly over the next couple of seconds. But you have seen before how the scale down works as well. So here the same thing that happens too. So now we have the full solution, pod autoscaling and node autoscaling in combination, working with each other, and that gives you really good cost-effective Kubernetes clusters that you don't have to monitor on the performance side because it happens so automatically for you. So here you see the first node has already been removed, cost has been saved, really cool how that all worked. Good, so then let's go back to the slides. So the Carpenter summary, Carpenter is really fast. So it's the first Kubernetes autoscaler that really works well, really works super fast. It's simple but powerful, so you can configure a lot. To set it up is not so easy. So because you need roles, you need node classes, you need node pools, node definitions, all of these things. To set it up initially is not so easy. If you need help there, reach out to us. We have that all modeled in Terraform, and we can help you utilizing that easily. Because we can use spot instances and also on-demand instances, it is very cost-effective. So we see clusters from customers that almost cost nothing on the EC2 side. So the overall setup with config and CloudTrail and CloudWatch is often more expensive than the EC2 instances of these customers. Carpenter is secure, is Kubernetes native, so it installs a couple of CRDs so that all these events are happening on the Kubernetes API. It's open source, so it's part of SIG autoscaling. Even if AWS has invented it, other cloud providers are starting to use it as well. You can also get it on Azure. Google has maybe something else, but other cloud providers are using it too. Good, so I think that's it. To Carpenter, and now to close off the presentation, how we have helped Sly is with our whole product portfolio. So we made some cloud consulting, we did a lot of automation, CI/CD, DevSecOps, with Terraform, also with GitLab pipelines. Of course, the whole AWS implementation that we did for them, the integration, and that really made it a whole solution for Sly and their customers. Now they can host really properly Velox on Kubernetes. We also have a Meetup. So the Meetup is quarterly happening here. So we talk a lot about containers on AWS. If you want to be part of it, also come, please. Of course, it's all free. We always serve pizza and beer. We are quite the nerds, so come and see and talk to us at these Meetups. I leave this up for a couple of seconds so that you can grab the QR code. Good. And that's it. Thank you so much for being here. If you need anything, AWS, Kubernetes, Carpenter, talk to us. We are here. We are a couple of folks here from copebit. Please raise your hand so that people can see who is all here from copebit. Thank you so much. Enjoy your evening. Thank you.